afternoon, everyone. So today we are going to be looking at conversions, angles and coordinates. So our intent for today's session is converting units of mass, capacity and length, converting imperial and metric units, looking at plans and elevations, coordinates of maps and calculations to do with angles. So in conversions, you will have to convert 3 sets of units based on a memory. So you need to know how to do these without any prompts on your exam. So that's converting units of maths, so grams and kilograms, units of length, millimeters, centimeters, meters and kilometers, and units of capacity, milliliters and liters. So we're going to go through each one of how you do each one. So first, we have units of mass. So when converting between units of mass, remember there are 1,000 grams in 1 kilogram. So to go from grams to kilograms, you divide by 1,000, and to go from kilograms to grams, you multiply by 1,000. Another simplistic way of doing it is thinking about that 1,000 grams is 1 kilogram. So 500 grams, half of this amount, is going to be half of this amount, so 0.5 kilograms. And then so 100 kilograms, 100 grams, if you think about it from a kilogram point of view, if 500 is 0.5, 100 will be 0.1 kilograms. And if you think of it like that, when you're dealing with decimals, it becomes much easier. But another way of looking at it is looking at what your thousands, tens and units are in your decimals. So say you have 3.25 kilograms and you want it to grams. Think your 3 is going to be your thousands, your 2 is going to be your tens, and your 5 is going to be, your 2 is going to be your hundreds, and your 5 is going to be your tens. So that would be 3,250. And that's a nice simple way of looking at it. Then say you've got 0.12. This is going to be your thousands. That's going to be your hundreds. And that's going to be your tens. Now we have no thousands. So we just have 100 and 2 tens. So we've got 120 grams. That's a nice simple way of looking at it. So here we've got 4,500 grams to kilograms. So here we've got 4 in the thousands. So we're going to put, but we've got only 500. So that 500 then be after the decimal 0.5 kilograms. So 4.5 kilograms. Then we've got 2.65 kilograms to grams. So we've got 2 in the thousands, 6 in the hundreds, and 5 in the tens. So if we're writing that in the number, 2,605 tens, which is 50 grams. Okay, now using that method, have a go now at 0.61 kilograms to grams and 240 grams to kilograms. Okay, so as we can see, we've got nothing in the thousands, but we've got 600 and then 1 in the tens. So our answer would be 610. And then the opposite way, because we've got 240, we've got nothing in the thousands, so there's going to be naught and point, because the number before our decimal point tells us it's 1,000. Then 24, and then nothing, so we don't need that for 0.24 kilograms. Okay, and that is units of mass. It is exactly the same now with milliliters and litres. Okay, so let's have a look at this one. We've got 6,500 millilitres to litres. So how many thousands have we got? That goes before our decimal point. So we've got 6. Tens, so we've got no tens. So we've got 6.0 5 in the hundreds column, and then nothing in the tens. So our answer is 6.5 litres. Then we've got 2.35 litres to millilitres. So how many thousands have we got? Well, we've got 2,000. How many hundreds have we got? Well, we've got 3. And how many tens have we got? We've got 5. So 2,350 millilitres. Okay, so as before, I want you to have a go now at 0.41 litres to millilitres and 210 millilitres to litres. Okay, so as we can see, we've got nothing in the thousands, 4 in the hundreds, and 1 in the tens. So 110 would be 10, 4 in the hundreds, 110 millilitres. And then here, 210 millilitres to litres, we've got nothing in the thousands, so we're going to put 0.2 in the hundreds and 1 in the tens. Our answer will be 0.21 litres. Okay, well done for those. So our next that we're going to look at is converting units of length. So this diagram is going to be your go-to whenever you are looking at conversion. So it's super important to put this somewhere where you see it every day, near your kitchen cupboard, in your bedroom, in your bathroom, and have this in your revision guide. So our small little units of length are millimetres that you'll deal with, and then our largest are kilometres. When we are converting from small to big, we are dividing in sets of 10. So when we go from millimetres to centimetres, we divide by 10. When we go from centimetres to metres, we divide by 100. And when we go from metres to kilometres, we divide by 1,000. And then when we're going the opposite, so kilometres to metres, we times by 1,000, metres to centimetres, we multiply by 100 and multiply by 10. So notice it's the same amount, small to big, divide, big to small, multiply. So let's have a look at these three. So we've got 30 millimetres now to centimetres. So what we do is, because we want to go from millimetres to centimetres, we divide by 10. So we're going to knock off that 0 in 30 and we're left with 3. Then 20,000 metres to kilometres. So we're going to go metres to kilometres, divide by 1,000. This time we're going to knock off 3 zeros, 2, 3, and we're left with 20 kilometres. And then our last one, we're going to go now from metres to centimetres. So this time we're going to multiply. So we're going to do 4 times 100, which is 400 centimetres. And that is how we convert between units of length. Sometimes in your exam, a question might ask you what a measurement is in kilometres or metres. So something that's much bigger than the one that it is, where it will require you to do a multi-step approach. If you need to convert to a measurement, for example, centimetres to kilometres, it's important to do the conversion in stages. So for example, here we've got 150,000 centimetres and we want to know what that is in kilometres. So step 1, we're going to do 150,000 to metres. So we're going to divide by 100, which leaves us, so we take away 2 zeros, with 1,500 metres. We then take that 1,500 metres and we divide it by 1,000 because we want it in kilometres. Now, one way to do this is to move the decimal point 3 places to the left. Now, a way to do this is divide by 10 3 times. So 1,500 divided by 10 would be 150. 1,150 divided by 10, which then be 15, and then 15 divided by 10, which then be 1.5. And it's a nice super way of checking that you've got that answer correct. So you've done that multiplication, division 3 times divided by 10. So let's now have a look at these 3 questions. So we're going to have a go at converting these 3 measurements from in a multi-step approach. So we've got 250,000 centimetres to kilometres. So we're going to write 250,000 and then we're going to write centimetres. First, we're going to go to metres. So we've got to divide by 100. And the easy way to do that is to knock off 2 zeros. So we're left with 2500, which is 2,500 metres. We're then going to take that 2,500 metres and we're going to move it to kilometres now. So now we're going to divide by 1,000. And an easy way to do this is to do it in sets of 10. So 2,500 divided by 10 would be 250. Divide by 10 again, which would be 25. Divide by 10 again would be 2.5 kilometres. And you have got your answer. So 250,000 centimetres to kilometres is 2.5. Okay, let's do that again with 40,000 millimetres to metres. So we're going to start with 40,000 millimetres and we're going to convert it to centimetres first, which is millimetres to centimetres. We're going to divide by 10. So we're going to knock off a 0, which leaves us with 4,000 centimetres. Then we're going to take that 4,000 centimetres and we're going to divide it by what we need to get to metres, which is 100. Now, this is much more simplistic because we've got zeros to deal with. So we'd knock off 2 zeros and we're left with 40, and that's our answer. So all we're doing is we're using this diagram to then help us convert. So the next one, we're actually going to do the opposite. We're going to have to multiply. So we're going to start with 0.25 kilometres and we're going to multiply it by 1,000 to get it to metres first. So here, what we're going to do is we're going to multiply it in sets of 10. So if we times that by 10, it'd be 2.5. If we times it again, it'd be 25. And then if we times 25 by 10, we'd be left with 250. So we've got 250 metres. And then we do 250 metres. We want it to centimetres, so we're going to times by 100. And the best way to do this is to add 2 zeros. So we're going to do 250, add 2 zeros. So we're left with 25,000 centimetres. And that is how we do conversions on multi-step approach. So we are now going to look at what happens if we have to convert what we call between imperial and metric measurements. So sometimes we need to convert between imperial and metric measurements. So a metric measurement is what we've just done. So like centimetres, metres, kilometres, grams, kilograms. Imperial are things like pints, ounces, inches and things like that. So you might need to convert between inches to centimetres, millilitres to pints, grams to ounces. And this you will not have to remember. They will give you what's called a conversion factor that looks a little bit like this. So 1 millilitre equals 0.25 pints. Okay, this is just an example. So whenever you have to find out if you're wanting millilitres or pints, think left to right multiply. And this applies for anything. Left to right multiply, right to left divide. So say you wanted to know what 10 millilitres was in pints, you would do 1 ml equals 0.25 and put your 10 millilitre underneath. So notice your millilitres on the left and you want to know what it is on the right. So you're going to do 10 times 0.25, which would then be 2.5 pints. And you've got your answer. So right to left multiply, right to left divide. So let's have a look at this in terms of a question. So a nursery manager is taking measurements of the new children. She uses the conversion guide below to work out the children's heights in centimetres and inches. So if 1 inch equals 2.53 centimetres, I want you now to have a go at working out James's height in inches, and I want it in centimetres. Sally's height, which is in inches, and we want it in centimetres. And Omar's height in centimetres, and we want that in inches. So remember, left to right multiply, right to left divide. and you can use a calculator for these questions. Okay, so let's now have a look at these. So we're going to do, notice our inches is on the left. So we're going to do 50, because we're going from right to left, 50 multiplied by 2.53, pop that in our calculators, and we're left with 126.5 centimetres. Then Sally is also in inches, so now we're going to do 53 times 2.53 to get what her height is in centimetres. 53.2.53 gives us 134.09 centimetres. And then our last one, Omar, because his height is in centimetres, so it's on the right, when we want left, we're going to divide. So we're going to do 152 divided by the conversion factor, which is 2.53. And we are left with 152 divided by 2.53, and we're going to do 60.079. Now we always want two decimal places, so because this is a 9, this 7's going to round up to 8, so it's going to be 60.08 inches. And that is how we do conversions of metric and imperial. So our next topic that we are going to look at is plans and elevations. So plans and elevations are a way of representing a three-dimensional shape on paper. We have three views of the 3D shape. From the front of the shape, we call this, what would be the pink, the front elevation, so what you can see from the front. From the side of the shape, we call this the side elevation, so that's what's in blue. And then from above looking down at the shape, what we all can call a bird's eye view, which is a bit in yellow, is the plan view. So in your exam, you might be given a shape or a certain image, and you're asked to work out what the plan or elevation is from the side, front, or from the plan view. So I've got two shapes for you on the left, and both shapes are identified that the arrow is looking from the front view. So what we are now going to have a look at is what those drawings would be if we were looking at them from the plan, the front and the side. So having a look at the plan view for shape A, if this is the front, the plan view would be looking down. So we would see from a plan view 3 squares right next to each other, and that would be our plan view. Our front view, we can see that we would see this box and then the box above. So we would see two boxes, one on top of each other. And then the side view, which would be from here, we would see 1, 2 boxes next to each other, one above this one, which would be here, and then one to the side. And that would be our side view. Then with shape B, we are now looking at what the plan view would be. So if we were looking above, we would see these 3 across, and then we would see the 2 here. So it would look a little bit like an L shape. So we'd see 3 here and 2 here. The front, as we can see, we would see the 2 here and 3 across. So another like an L shape. And then the side view, you would see this box, we would see this box, and then we would see the 2 across. So we would see 2 and then 2 across again. And that is how we can identify plans and elevations. So our second to last topic that we are going to have a look at today is coordinates. So when you are using coordinates, especially on a 4-point grid, the x-axis is first and the y-axis is second. It can be remembered by thinking you go along the corridor and up or down the stairs. So we always read across first and then up or down. So the coordinates of 4 quadrants. So here we have the first quadrant, and when all your numbers are positive, and we write our coordinates in brackets with a comma in between. So we've got 4 and then 3. Our next quadrant is one number is positive and the other one is negative. So as we can see, our x-axis is negative at -4, but our y-axis is positive at 3. So our coordinates will be -4, 3. Then our third quadrant, both numbers are negative. So we've got -4, 3. And then our last quadrant, one is negative and one is positive. So our x-axis is positive and our y-axis is negative. So 4, 3. And we would write them in brackets with a comma in between. So looking at the grid on the left-hand side, what would be the coordinates of C? So we go across and then we go up. So our coordinates would be 5, 6. What would be the coordinates of point A? So we go across and then up. So our coordinates would be 2, 1. And then if ABCD is a rectangle, what are the coordinates of point D? So we know a rectangle, 4 equal sides, so 1, 2 equal here, 2 equal here, so 2 pairs of equal sides. We know that if we did it here, it's not going to quite match. If we did it here, it's not going to quite match. But if we plotted our here and then we drew a line, we would then end up with a very nice shaped rectangle. So our coordinates of B would be 2, 6. Fabulous. And that is coordinates on a grid. Sometimes we might need to draw or understand coordinates of maps. So when reading coordinates of maps, we read across the x-axis, focusing on the first digits. So for example, here is 38, and we count until we reach our point. And then count the y-axis, focusing on the first 3 digits. So here is 43, and count until it meets the point on the x-axis. So what are the coordinates of the hotel? So our hotel is here. So notice we start at 38 and we're going to go 4 across, 1, 2, 3, 4. And then we're going to read our y-axis, which is 43, 1, 2, 3, 4, and it meets here. So our coordinates are 38, 4, 43, 4. And I'm just breaking it up like that so you can see each axis, but you would write them without any spaces or commas in between. So using that knowledge, I want you now to have a go at writing the coordinates of Oakwood, the church, and Highby Station. Right, so first we have Oakwood, which is here. So we're going to look at our x-axis. So we've got 38, 1. And then what on 43? 43, 1, 2, 3, 4, 5, 6, 7. So our coordinates are 38, 1, 43, 7. Then the church. So here we've got 38, 8. And then 43, 5. And then our last one at Highby Station, which is here, 38, 6, 43, 9. And that is coordinates and coordinates of maps. So our last topic that we are going to be looking at today is the calculation of angles. So angles in a triangle refers to the sum or total of the angles at each vertex or corner in a triangle. the sum of the interior angles of a triangle are 180 degrees. So all you need to remember as one point with triangles for your exam is that they add up to 180 degrees. So first we have a right angle triangle, which you know is 90. So to work out the angles, if you were only given one of these and you were given 55 and 90, remember this angle and this angle and this angle all make 180. So you would do 90 add 55 add 35 to give you 180. We then have an isosceles triangle, and these lines mean equal sides and angles. So these two angles will be the same. So these two add this one will make 180. Then we'll have an equilateral triangle. So we do 180 divided by 3, which is 60. So on an equilateral triangle, they'll always have the same. And then a scalene triangle will have different sides. So they're all the angles of triangles to navigate. Then the other four to remember. So the angles of a straight line, so when you see a straight line, all the angles around here will add up to 180. So x plus y plus z equals 180 degrees. Angles around a point will add up to 360. So w add x add z add y equals 360 degrees. Opposite angles, so x is equal to x and y is equal to y, are all equal. So x and x are the same, y and y is the same. And then the angles of a quadrilateral, so a four-sided shape, are equal to 360. So w add y add z add x equals 360. So they, in addition to your triangles, are all the angles you will need to know for your exam. Now, the exam board are not going to make it as simple as that possible. They'll just give you one. They might give you a shape that contains several of these angles within, and you've got to problem solve by adding and subtracting and knowing your rules for each shape to solve those problems. So, calculate the following missing angles. So we've got A, and then we've got B. So I want you to have a look at A. Which of your angles is it? Is it a straight line? Is it around a point? Is it a triangle? And we have around a point, which we know is equal to 360 degrees. And we've got 110, y, and then here. We know that this is 90 degrees. So 110 add 90 add y must equal 360 degrees. And we know if we add 110 and 90, so 200, add y equals 360. We then want to work out what y is, so 360 take away 200, and we're left with 140 degrees. So y is equal to 140 degrees. Then we have B. So work out the size of angled marked X. So here we've got a quadrilateral. We know they're equal to 360 degrees. We also have a right angle, which is 90 degrees. So what we're going to do is we're going to add up all of these first to then work out this angle, because if this one and this one, so this mystery angle plus here is a straight line, it's going to equal 180. So we've got to do the interior bit first here before we even start dealing with X. So we've got 108, add 125, add 90, add our mystery one equals 360. So 108 and 125 and 95, so 108, 125, 90, so let's add all those up. 8 and 5 is 13. 9 and 2 is 11. It's 12. Is 323. So we've got 323 add our question mark equals 360. So we're going to take away 323 from 360, which leaves us with 37 degrees. So we know that this one is now 37 degrees, and we know 37 plus x equals 180. So now how are we going to work out what x is? We're going to do 180, take away our 37. So notice we're problem solving at every element is 143 degrees. X is 143 degrees. So we had to solve what a quadrilateral was to then work out the angle of that straight line. And that is conversions, coordinates, and angles. So all you need to now do, rewatch the video if needed, and then complete the worksheet attached.